grade school, the solar system is the group of local planets, asteroids, and other small objects that orbit our sun. Traveling outwards from the sun, we have Mercury, Venus, Earth, and Mars. After Mars comes the asteroid belt, a chaotic cluster comprised mostly of rock and metal. Then come the gas giants, Jupiter and Saturn, followed by the icy outer planets Uranus and Neptune. Beyond Neptune lies trans-Neptunian objects, including things like comets, dust clouds, natural satellites, and dwarf planets like Eris and Pluto. Finally, and far beyond everything else, there's the Oort cloud, a theoretical cloud consisting of space dust and debris that marks the solar system's end. While experts firmly believe that this cloud exists, no direct observations have been made of it. It's just too far away. But just how far does our solar system spread? What would you have to do to reach its outer edges? And how long would it take? Luckily, we have a nifty little device called Voyager 1 offering up a point of reference, traversing the outer reaches of our solar system as we speak. The Voyager 1 space probe was launched by NASA on September 5th, 1977, and is currently still traveling at around 35,000 miles per hour. It reached Saturn, its primary target, in November 1980. But on August 25th, 2012, nearly 35 years after launch, it made even greater history by becoming the first spacecraft to enter the interstellar medium, a fancy term for the space between star systems in a galaxy. More specifically, Voyager 1 broke from the reach of the sun's solar winds and entered into deep space. It's currently at a distance of 21.2 billion kilometers from the sun and is so far away from us that it takes a radio signal traveling at the speed of light roughly 17 hours to beam between the spacecraft and our home planet. Sounds like a lot, right? Well, while the monumental achievements of Voyager 1 should never be underestimated, we're still very far from making an even semi-significant dent in the solar system as a whole. It would take Voyager 1 another 300 years just to reach the inner edge of the interstellar Oort cloud, and up to 40,000 years to breach the cloud and finally break free from our solar system completely. In truth, the solar system, and space in general, is just way too big for earthly measurements like miles and meters. To measure distance in space, astronomers use something called an astronomical unit, with one unit equaling the average distance from Earth to the Sun, or 150 million kilometers. If you were to somehow drive a car to the sun at highway speeds of 100 kilometers per hour, you'd eventually reach your destination in 1,500,000 hours, or 171 years. So no one's surviving that. But let's say you splashed the cash, pulled some strings, and took the fastest air-breathing manned aircraft in the world, the Lockheed SR-71 Blackbird. Traveling at constant top speed, it would take you just 42,492 hours to reach the sun, or just under 5 years. In contrast, definitely doable. But let's be serious. The distance from the Earth to the Sun is infinitesimal when compared to the size of the entire solar system. Way out there is everyone's favourite dwarf planet, Pluto. Pluto ranges from 30 to 49 astronomical units away from the Sun. So at its average distance, it's almost 6 billion kilometers away. Light traveling from the sun takes about 5.5 hours to reach Pluto. Driving a car at highway speeds, it would take you 6,849 years. But as we've established, the solar system extends far beyond Pluto. The outer edges of the Oort cloud are about 100,000 astronomical units away, or about 1.87 light years, or 17 trillion kilometers, give or take. Amazingly, the sun's gravity can capture objects as far out as 2 light years away, meaning that the outer part of the Oort cloud is still theoretically shaped by the sun's gravity. Just beyond the cloud's outer edges is the halfway point between our sun and the next nearest star, Proxima Centauri. Beyond that, you're swapping systems. So, in boring astronomical terms, it'd take you nearly 2 years to reach the outer boundary of our solar system if you were traveling at the speed of light. But we can't do that, can we? Let's hop back into our hypothetical space car and go for the ultimate cruise. Hell, you know what? Let's do one better. Let's forego the standard highway driving and up the stakes. Let's pretend we're in the fastest street-legal car in the world, the Bugatti Veyron. And let's imagine we can travel at its max speed of 431 kilometers per hour. Heading for the Oort cloud, traveling at the top speed of the fastest car in the world, it'd be 4.5 million years before you finished your trip. And that's without stopping for fuel or snacks. Now let's again pilot the fastest ever aircraft, the Lockheed SR-71 Blackbird. The Blackbird's 8 times faster than the Veyron at top speed, so the trip does shorten. But it'd still take you an eye-watering 550,000 years to reach the fabled finish line. Finally, let's say we hitched a ride on NASA's New Horizons probe, which left Earth at a staggering and record-breaking 58,536 kilometers per hour. It took this probe 9 years to fly by Pluto, so even if it continues its unprecedented pace, it won't breach the Oort cloud for another 30,000 years or more. How long it takes to cruise the solar system depends entirely on what you want to cruise in. In just your standard supercar, 4.5 million years. In a high-tech spacecraft, 550,000 years. On a NASA probe, the fastest object ever launched from Earth, 30,000. No matter what you travel in, you'd be long dead and space dust before you'd even consider the Oort cloud. Of course, if you chose to travel at light speed, you're looking at around only 1,000 days. But A, that's impossible, and B, that's cheating. So yeah, the solar system's pretty darn big. And remember, it's just one small speck in the Milky Way, which is but a tiny grain in the grand scheme of the entire universe. So next time you're complaining about your daily commute, remember this video and relax.